Hello ladies and gentlemen, my name is Inks and I'm from IGS Electronics. Today we're going to be getting into our temperature PID control in our TIA portal setup. This is a continuation of the videos we already did in the last two of the videos we've done. And our main goal is to use this cup of water, which is Mr. Grumpy's cup of tea, I call it, to heat it up to 80 degrees and maintain it on 80 degrees. So we're going to need to configure our controller, tune our controller, so it does exactly what we want it to do. We already done the videos about wiring in and setting up our temperature probe. We already done a video setting up and wiring our solid state relay. Now we can jump on a technology block called PID. So, and that's exactly what we're going to do doing today. And I'm not sure how many videos it's going to take. So there's quite a lot to discuss and show, especially because I want to set it up on my HMI screen as well, so we can control it from HMI and read it and things like that. So we'll be doing step by step, and I'll show you how I do that. So yeah, without further ado, let's get started. So the quick recap that we've done already in previous videos, you can see this is our digital output card that is going to send a signal to our solid state relay that we've done in the last video. There's a cup of water with temperature probe and heater in it already, and that temperature probe is wired into this card. So yeah, that's pretty much that. So from there on, let's jump on to our TIA portal, and first you could see in here I created a small on-off switch. My PID controller is going to be on all the time, so I want to have a switch on my HMI, which you're going to be doing in the next video, so I can turn it on and off so there's no signal going out to my output. So basically this is going to come from PID controller, this is going to be my HMI switch, this is a physical output that sends the pulses to the actual solid state relay. So as a Siemens says, all technology block should be called in cyclic interrupt, and that's exactly the block we are going to do. So then yeah, that's fine. So let's create a cyclic interrupt OB block. So from there on, let's go into instructions, technology blocks. Let's just remove that. PID control, PID compact. And in here, you got three options in here. Because we're going to be doing temperature, Siemens has created the block, PID block, specifically for the temperature. So how about we do that? So it's specifically done for temperature control. Double click it. Temperature turn 2, yeah, that's fine. And here we go. So our PID DB block has been created. From there on, we're gonna add a couple of values. For physical input, we have a set point in here, which I'm gonna leave blank as it is, because I will be able to edit that set point from HMI. We're gonna show it in the end of the video how. So and physical input is actually input PER. I think this is internal. I've never used it. This is something a kind of value from real for no. We need this one, which is a current value from peripheral input. I can't say. Basically, you can read what it is. So that is going to be our temperature input. So from there on, so if you click a little list, remember in a couple of videos ago, we created this tag. So let's click on it, and that's our temperature in. From there on, as you can see, output heat, output cool, that is in 0 to 100%. Pretty much we're going to be showing us how much heat is outputted in percentages, and how much cold if you are using for cool, and how much cooling is output and things like that. So we have two options, as you can see in here, for heating and cooling. Two options. So one of them, if you go over it, as you can see, analog output value for heating. Now we have a solid state relay that goes on and off, so that's no good for us. And then you go for the PWM, which is, as you can see, a pulse width modulated output value, which is a Boolean. So that's the one we're going to be using because it's going to be on and off. So in here, we're going to go into our tag. So, and that is this guy in here, PID T1L. And that is pretty much all the signals that we need to provide to this technology block, for this PID block. So there's nothing else really when it comes down to providing, for my view, nothing else we need to give him, because everything else is just not necessary. So let's go into configuration, because that's what we're going to do in the video. We're going to do the configuration. Commissioning is going to be in later videos, because that's separate, something I want to do separately. So let's go into configuration. As you can see in configuration, we have it says controller type, what kind of type it is. Because it's already been preset for temperature, there's only just temperature in general. Temperature, you can choose what is a C, Fahrenheit or Kelvin. And another thing I'm definitely going to say activate mode after CPU restarts, which is going to be, in our case, automatic. It's just a PID controller is going to be on at all times. So there's other ways to do it. From manual, go jump from manual to automatic, but I don't want to do that. So, and then as you can see, we already set up all this. There's nothing we need to do in here. Cascade, nothing to do in here. Process values. In here, we're going to set what our maximum process value is going to be. I want to, for my tuning later on, I'm going to set this a little bit higher, because so I don't have to do the fine tune. So basically, set your process values, high limits and low limits, and then we need to scale it. So as you can see in the scale in here, we're going to change that to 120, and by default, guys, as you can see in here, it says 120 degrees is going to be 27,648. Well, that's not the case, because if you remember if you have watched when I was setting up the thermocouple, 1 degree was 10. 2 degrees was 20, 3 degrees was 30, and so on and so on. Hopefully that makes sense to you. And then we need to say scale high process value to 1200. 1200, make sure that is done. Otherwise, things are gonna go really bad. So from there on, all of this after that is just the basic stuff that you can play with, and if you do need to play with. So we're not gonna touch any of that. So from that point, from configuration point of view, we are pretty much ready to go. So next thing, let's load this in. So but what I'm going to do, I'm going to go from here and load it from here. So we're going to have a quick check up on it, because we still need to do quite a bit on HMI, and I'm going to do that in the next videos, like a separate video, because a lot of people maybe don't want to see that, so they can jump straight to tuning, which is going to be video after. So I haven't done that, so let's go into cyclic interrupt and put a Mr. Glassy Man on. And as you can see in here, if you go off it, my PID controller is all green. So it says I'm on. I'm working, but it says I've got no set point. So as you can see, our flag in here shows a false. So it's pretty much off. It's doing nothing. So let's change our set point and give him a, let's say, a 50 degrees. So remember, guys, the controller is not tuned, so he's going to be working whatever values he's already got. He doesn't know what values he's got. He's just going to try to get to that set point no matter how. Whatever he's got now as a default. So let's load that value in. Yes. And as you can see now, the output is pulsing. True, false, true, false, true, false. And our heat output, as you can see, the heat output heat is 65%, and it's growing and growing and growing. So it's trying to heat it, but no temperature change. So it keeps checking, and it says, oh, I gotta go a bit higher. I gotta go higher. Temperature is not changing. So eventually, it's just gonna go all the way to 100%. But he's doing it so slow because it hasn't been tuned, so he doesn't really know when can he actually go to 100%. That's why tuning is so crucial. And as you can see now, it's going to 100%, and he's always on. But nothing's changing because our heater right here is off. So the output in here is unable to receive that signal. So that's what's crucial. In case in emergency, we need to turn things off, we have that option. So I haven't done that. So our controller is ready for pretty much ready for the tuning. But first, what I want to do, I want to set up the HMI, and we're going to do that in the next video. But before we jump onto the next video, I'm going to show you where we're going to be getting those values from. So if you go in a PID, but all the associated data files or anything associated with this controller it's here. So if you go into, did I say that? So go right click it and go the Open DB editor, and in here you can see, if you expand it, and it tells you what each of these blocks can do. Blocks of data files can do for you. So as you can see, it's accessible from HMI, OPC, web. It's bloody hell, writable from HMI and visible in HMI engineering, and all of these we can add onto HMIs, remove, and it explains you in here what each thing is. And as you can see in here are a set point controller, set point input. We'll be able to put that on a HMI and edit it directly from there. How about that? But for that, ladies and gentlemen, we're gonna play on that. We're gonna set that up on our HMI in the next video, and then we're gonna jump on to the tuning. And then, let me just do that. We'll do for this video, ladies and gentlemen. Hopefully this is giving you a good starting point where we are, how we got to that point. And we can continue in the next video. Hopefully I've done my best to explain what is what and how it works. And you're on your way to doing your own thing now. So yeah, thank you very much for watching. If you liked the video, don't forget to smash that like, do subscribe if you're new to the channel. And if you like what we're doing here, and I'll see you next video.